Welcome, performance enthusiasts! Today, we're dissecting the process of constructing a cutting-edge gaming PC for 2025. This isn't your average beginner's guide. We're delving into component selection rationale, architectural considerations, and maximizing system-level performance with the latest hardware. The foundation of any high-performance build lies in the synergistic selection of core components. We'll be evaluating current top-tier architectures for optimal gaming throughput. For the 2025 landscape, we're considering the latest high-core count, high IPC or instructions per clock processors from both AMD and Intel. On the AMD side, this includes the Zen 6 architecture-based Ryzen 9000 series, like the Ryzen 9 9550X, leveraging advancements in core density and process node refinement. Intel's contender would be their Raptor Lake refresh successor, for example, the Core i9-15900K, emphasizing a hybrid P-core and E-core architecture with enhanced thread management and clock speeds. The choice hinges on workload priorities, but for pure gaming, both offer compelling high-end options. So, the motherboard really dictates component compatibility, power delivery, and expansion capabilities. For the CPUs we've mentioned earlier, we're looking at the latest flagship chipsets. AMD's X870E offers enhanced PCIe 5.0 support for both graphics and NVM, while Intel's Z890 provides similar high-bandwidth connectivity and robust VRM designs. These are crucial for sustaining peak CPU performance, especially under overclocking scenarios. Now let's analyze some key features, like VRM phase count and quality PCIe lane allocation, and also integrated high-speed networking. Think 2.5 GBE or even higher. These factors, honestly, can make a big difference in the overall performance and stability of your build. High-speed, low-latency DDR5 memory is, well, absolutely paramount. We're targeting at least 32 gigabytes, that's 2 sticks of 16 gigabytes, of DDR5 running at speeds of 7200 megahertz or higher. And of course, we'll want to pay close attention to XMP 3.0 or Expo profiles for optimized timings and voltage. The impact of memory speed on 1% low frame rates, particularly at higher resolutions, cannot be overstated. The GPU remains the primary driver of gaming fidelity. In 2025, we anticipate the release of next-generation architectures from both NVIDIA and AMD. So our focus is on the high-end segment here, probably the NVIDIA GeForce RTX 6000 series, like say the RTX 6080 Ti. These cards are anticipated to bring some pretty big advancements in ray tracing hardware, updated tensor cores for AI-driven upscaling with DLSS 4, and increased memory bandwidth as well. Now, the AMD equivalent would be the Radeon RX 9000 series, for example, the RX 9900 XT. This lineup is expected to compete with improvements from the RDNA 5 architecture, which is really focused on boosting raw rasterization performance and, of course, Fidelity FX Super Resolution, or FSR. At the end of the day, the selection is really going to depend on your individual game preferences, and honestly, the maturity of each manufacturer's upscaling technologies. Both our chosen motherboards and next-gen GPUs will utilize the PCIe 5.0 interface, offering double the bandwidth of PCIe 4.0. This ensures optimal data transfer rates between the GPU and CPU, minimizing potential bottlenecks, especially at high refresh rates and resolutions. Maximizing system responsiveness and thermal management are, honestly, critical for sustained high performance. We'll employ a multi-tiered storage solution. The primary boot drive, and for frequently played games, will be a 2TB NVMe PCIe 5.0 SSD, with sequential read and write speeds exceeding 10 GB per second. For secondary storage, a 4TB NVMe PCIe 4.0 SSD offers a balance of speed and capacity for a larger game library. The architectural shift to direct storage APIs, really emphasizes just how important high-speed NVMe drives have become for reducing game load times and improving asset streaming efficiency. High-performance components, well, they generate a significant amount of heat. Our cooling strategy will involve a premium 360mm or 420mm all-in-one liquid cooler for the CPU, chosen specifically for its thermal dissipation capacity and pump efficiency. For the GPU, the cooler is integrated by the manufacturer, but we'll be sure to consider models that have robust heat sink designs and triple fan configurations. Now, when it comes to the case, we'll prioritize high airflow by selecting one with a mesh front panel and strategically placed high static pressure fans to ensure proper heat evacuation. We'll also analyze fan CFM, which stands for cubic feet per minute, as well as static pressure ratings. A stable and efficient power supply, honestly, is non-negotiable for a high-end system. We recommend going with a high-quality 1000-watt or even 1200-watt 80+ gold or platinum certified PSU from a reputable manufacturer. This will give us plenty of headroom for our power-hungry components and any potential overclocking, all while ensuring efficient energy conversion and stable voltage delivery. So let's talk a bit about why single versus multi-rail designs matter, and, why Japanese capacitors are often recommended for longevity. These factors can really make a difference in how reliable your components are over the long run. When you're planning your build, it's important that the case you choose allows for optimal airflow and good cable management. Generally, full tower or spacious mid-tower cases with well-designed cable routing channels and grommets are preferred. You'll also want to think about things like how many fans you can mount, radiator support, and honestly, just how easy it is to install and upgrade your components down the line. The assembly process, well, it really demands precision and a lot of attention to detail. All right, let's dive in. It's always a good idea to consult component manuals for specific installation procedures. Make sure to follow those motherboard-specific instructions for CPU mounting. Next up, apply a high-quality thermal interface material. This step is super important for efficient cooling. And finally, secure the AIO cooler, ensuring you've got the proper mounting pressure. Now let's get the memory installed. Place the RAM modules in the designated slots to achieve the best dual-channel or quad-channel configuration. Don't forget to enable the XMP or Expo profile in the BIOS for optimal performance. Moving on, install NVMe SSDs into the appropriate M.2 slots. This will give you both speed and security for your storage needs. Alright, let's securely mount the motherboard within the case. Next up, insert the GPU into the primary PCIe 5.0 by 16 slot, and don't forget to connect the necessary PCIe power connectors. Now install the PSU and connect all necessary power cables to the motherboard, GPU, and storage devices. Be sure to prioritize meticulous cable management for optimal airflow. Alright, now it's time to connect the power switch, reset switch, USB ports, and audio headers, and make sure you do it according to the motherboard manual. Post-assembly configuration is, honestly, super important for maximizing performance and stability. When you first boot up, go ahead and enter the UEFI or BIOS settings. Double-check that all your installed components are recognized. Then, set the boot order to your installation media. Don't forget to enable the XMP or Expo profile for your RAM. And if you're feeling a bit adventurous, explore advanced settings like resizing bar for some potential performance gains. Alright, now it's time to install your preferred operating system, like say Windows 11. Just follow the on-screen instructions and you'll be up and running in no time. Next up, you'll want to download and install the latest drivers for your motherboard chipset, GPU, and any other peripherals, and be sure to get them directly from the manufacturer's websites. This step is super important because it ensures optimal compatibility and performance across your whole system. Now let's put your new rig to the test. Utilize industry-standard benchmarking tools such as 3DMark or Cinebench to evaluate your system's performance. And for a bit of peace of mind, conduct stress tests like Prime 95 or FurMark to assess thermal stability when your PC is under load. This meticulously engineered gaming PC really represents the apex of current hardware, capable of delivering uncompromising performance even in the most demanding titles out there. Understanding the architectural nuances and how each component works together is honestly paramount to achieving this level of capability. For more in-depth analysis and detailed performance metrics, just refer to the accompanying documentation and links provided below.